Hello everyone. Today we'll be solving AQA GCSE Chemistry May 2020 Foundation Paper Part 1. Question number 1 to question number 4 will be solved in this particular video. Question 1. This question is about the elements in group 7 of the periodic table. Table 1 shows the melting point and boiling point and some of the elements. Element melting point in degrees Celsius, boiling point in degrees Celsius given. What is the state of bromine at 100 degrees Celsius? So let's look at bromine. Bromine boils at 59 degrees Celsius. Since bromine boils at 59 degrees Celsius, so at 100 degrees Celsius is going to be a gas. What temperature does chlorine gas condense at to form a liquid? Okay, so we need to know at what temperature the chlorine gas will condense. We know that condensation occurs at the same temperature as that of the boiling point. However, the only difference is it needs to be cooled down at that particular temperature. So here we can see minus 35 degrees Celsius is the boiling temperature. So this will also be the condensing temperature. So minus 35 degrees Celsius will be the answer. 1.3. Complete the sentences. Going down the group 7, the melting point. Okay, so we can conclude from this particular table that from fluorine to bromine, the boiling point is increasing. So BP is increasing. Alright, so going down the group 7, the melting point and the boiling point, both of them are increasing. So increases. This is because the size of the molecule increases, so the intermolecular force. So if the molecule size increases, all right, the intermolecular force between the molecule will also increase. A teacher investigated the reaction of iron with chlorine. Figure 1 shows the apparatus used. So chlorine gas, we are passing it through iron wool and excess chlorine is getting out from here. Okay, it's a glass tube. Why did the teacher do the investigation in a fume cupboard? Okay, first of all, we need to understand that chlorine is toxic. So since chlorine is toxic, we need to do this particular experiment in a fume cupboard. The word equation for the reaction is iron plus chlorine producing iron chloride. Iron chloride is a solid. Actually, iron chloride is a salt, so definitely it's going to be a solid. The teacher weighed the glass tube and contents before the reaction, after the reaction. What happened to the mass of the glass tube and contents during the reaction? Give one reason for your answer. So since the chlorine was a gas and it combined with the iron to produce iron chloride, so the mass will increase. So the mass of the glass tube and its content will increase. Okay, the reason for this will be chlorine atoms are now part of the solid iron chloride. They are now. The teacher repeated the investigation with bromine gas and with iodine gas. Table 2 shows the result. Chlorine, iron burns vigorously with the orange glow. Bromine, iron burns with the orange glow. Iodine, iron slowly turns darker. This indicates that the reactivity is going down. Reactivity going down, reactivity decreases. Fluorine is above chlorine in group 7. Predict what you would observe when fluorine gas reacts with iron. So we can expect a very violent and vigorous reaction. Balance the equation for the reaction between iron and bromine. So we have 2 Fe and it is producing FeBr3. So we can see this 2 will get multiplied with the 3, so which makes it 6. So we need to put a 3 here so that the 3 multiplies with the 2 and makes 6 bromine. We need to have equal number of atoms in both sides. Calculate the relative formula mass Mr of FeBr3. To calculate the relative formula mass Mr, we're going to write it like this: Mr FeBr3. Fe is 56, bromine is 80 times 3, so the total will be 296. This question is about models of the atom. Atoms were first thought to be tiny spheres that could not be divided. Which particle was discovered to change this model of the atom? Electron was invented, alright, it was discovered to change the model of the atom. Electron proved that the atom could be divided into smaller particles. Figure 2 shows another model of atom. What is the name of the model of the atom? So this particular model of the atom is called plum pudding, where it is considered the atom is just like a plum pudding, and the positives and negatives, they are just scattered all around. A scientist fired particles at gold atoms. Some of these particles were scattered. The results led to a different model of the atom. Which type of particle was fired at the gold atoms? So the scientist actually fired alpha particles. Alpha particles, all right, is technically it's a helium ion. Helium has a mass of 4 and 2 protons. But when it is 2 plus charge like this, then we call it a alpha particle. So the scientist has, the scientist shoot alpha particles, all right, from an alpha particle emitter. Which scientist first suggested that electrons orbit the nucleus at specific distances? So basically, Mr. Bohr, all right, he was the first scientist. He suggested that the electrons orbit the nucleus at specific distances. The model of the atom used today has 3 subatomic particles: electrons, neutrons, protons. Complete the sentences. Atoms of the same element have the same atomic number because they have same number of protons. If they have the same number of protons, we call them same atomic number. Atoms of the same element can have different mass numbers because they have different number of neutrons. Neutrons are neutral, so they only determine the mass of the particular atom. So they can form, because of different number of neutrons, atoms can form isotopes, but the identity of the atoms are considered using their proton number. So as long as the proton number is equal, the atom should be the same. Atoms have no overall charge because they have the same number of, so they have the same number of protons and electrons. 2.6. The radius of a nucleus is approximately 1 into 10 to the power of minus 14 meters. The radius of an atom is approximately 1 into 10 to the power of minus 10 meters. A teacher uses a ball of radius 1 centimeter to represent the nucleus. So to represent the nucleus, the teacher uses 1 centimeter ball. Alright, 1 centimeter divided by 100 equals to 0.01 meters. Alright, now to represent the atom, which is 1 into 10 to the power of minus 10 meters, we can see from here to here it increases by a factor of 10,000. Alright, how can I tell that? You see, this is minus 14 and 10, so 14 means 4 zeros. Okay, so we just multiplied that by 4 zeros. Okay, so if it is 0.01 meter for the radius, then multiplied by 10,000 would give us 100 meters. So it will be, the answer will be the sports arena of radius 100 meter. This can be used to represent the radius of an atom. This question is about chemical reactions and energy. Hydrogen reacts with oxygen to produce water. This reaction releases energy. Complete the word equation for the reaction. So when hydrogen reacts with oxygen, obviously it's going to produce water. Okay. Figure 3 shows a reaction profile for the reaction between hydrogen and oxygen. Okay, great. So we can see here we can represent the reactants. Okay, and W will represent energy. Z will represent reaction pathway. Y will represent enthalpy change or energy change. And X will represent activation energy. What do the labels W, X, Y, Z represent? Choose answers from the box. So, W will represent energy. Alright. X is activation energy. Okay, so I'm just writing X here. Alright. And Y is overall energy change or enthalpy change. Okay. Alright, Z will represent progress of reaction. Okay, guys. The reaction between hydrogen and oxygen is used in hydrogen fuel cell. What is the reason for using this reaction in fuel cell? So options are to produce a change of state, to produce potential difference, and to produce temperature change. The purpose of a fuel cell is to produce a voltage difference, which is potential difference. A student investigated the voltage produced by a chemical cell. The student used different metals as the electrodes in the cell. The metals used were copper, iron, magnesium. Which two metal electrodes would produce the greatest voltage when used in the chemical cell? Okay, great. So basically, in order to produce the highest amount of voltage, we need to have metal with the most reactive and the least reactive. So here the most reactive is magnesium and the least reactive is copper. So we can use copper in one electrode and magnesium in the other electrode. And the reason why we are using it is because these metals have the largest difference in reactivity. Question number 4. This question is about electrolysis. A student investigated the hypothesis. The electrolysis of a salt solution produces a metal at the negative electrode and a gas at the positive electrode. Figure 4 shows the apparatus used. Figure 4. DC power supply. We can see graphite electrodes and we can see salt solution. What observation would be made at each electrode if the hypothesis is correct? Okay, so let's review the hypothesis one more time. The electrolysis of a salt solution produces a metal at the negative electrode and a gas at the positive electrode. Observation if metal produced at the negative electrode. So, if metal is produced at the negative electrode, alright, we will definitely see a solid being produced. And observation if gas produced at the positive electrode, definitely gas will form bubbles. So we're going to say bubbles or fizzing. Table 3 shows the student's result. With copper chloride, the product of the negative electrode is copper and the product of the positive electrode is chlorine. potassium nitrate, we get hydrogen and oxygen. Silver nitrate, we get silver and oxygen. Which two salt solution in table 3 does not match the student's hypothesis? So basically, we can say that potassium nitrate, this one doesn't match. So the salt solution, potassium nitrate. The reason is, hydrogen that is produced in the negative electrode is not a metal or not a solid. Give two reasons why the graphite is used for the electrodes. Okay, the main reason why we use graphite, one of the biggest reason is graphite is a very good conductor of electricity. And the second reason we would want to use graphite is because it's very inert or unreactive. We want our electrodes to be very unreactive in order for it to, not react with the electrolytes that it is in contact with. A different student investigated what happens during electrolysis. Figure 5 shows the apparatus. We have DC power supply, negative electrode, positive electrode, purple crystal, filter paper soaked in electrolyte solution. The purple crystal contained colorless positive ions and purple colored negative ions. The purple crystal dissolved in the electrolyte solution. What happens to the purple colored ions? Give one reason for your answer. So as you can see, the purple color ions, they are negatively charged. So the ions do not move. The ions move towards a negative electrode. The ions move towards the positive electrode. So definitely, since it is negatively charged, that's why it will move towards the positive electrode. All right. The reason will be the positive electrode attract ions of the, opposite charge, which is the negative charge. All right. So all right, guys, that's the end of this particular video. Guys, I'm gonna be uploading question paper solutions like this. All right, and definitely some of you will be benefited. All right, if you have any further questions, you can let me know in the comments, and I will definitely try to get back to you regarding your confusions. And guys, this particular video production, all right, currently at the moment is quite expensive. All right, if you want to donate something, all right, there are students of mine, those who does contribute a little bit. Let me know in email. All right, and I'll definitely get back to you about that. And for those who are just wanting to benefit from this, please go ahead and watch the full video. All right, it's always free, it's in the YouTube. All right, and watch the full video. All right, recommend it to your friends. What can I say? Best of luck for your exam.